Next, we're going to talk about the second fundamental theorem of calculus. And there's only two, and it rounds out our thinking about the relationship between derivatives and integrals. Here it says if f is continuous on an open interval I containing a, then for every x in the interval, the derivative with respect to x of the definite integral from a to x of f of t dt equals f of x. So basically, we can think about this right here as being inverse operations. So the derivative undoes the integral. So the first fundamental theorem of calculus says that integration undoes differentiation. Okay, and that's why the antiderivative can give us our integral. Now the second fundamental theorem of calculus says that differentiation undoes integration. So taken together they complete the notion that differentiation and integration are inverse processes. Okay, another way of looking at this would be like this. So d over dx, so the derivative of the definite integral with respect to x is just going to equal the function f of x. For an example, if we did something like this, if we want to find the derivative of sine x, that's going to equal the derivative with respect to x from 0 to x of cosine t dt. Okay, and this is kind of what we were just looking at. Okay, so from 0 to x of cosine t dt is sine of x. Right, and that's what we just found in that last example. And so if I take the derivative of that, then I'm going to get the derivative of sine x. And what's the derivative of an integral? Well, these cancel each other out, and so all we're left with here is cosine of x. So this is kind of an example of how that works. Okay, now you'll notice here the notation that this x and this x have to match, and this is going to be a function of some other variable right here. And so if we wanted to evaluate the definite integral, if we wanted to evaluate the derivative of the definite integral from 0 to x of the square root of t squared plus 1 dt, okay, this becomes a very simple process. We see this and it undoes each other. So this is just going to equal the square root of x squared plus 1. And so we have to realize that this means it's going to become a function of x. And so we can just plug in our x for our t right there. Now one note here, this dt, if we have the derivative of dt, well, that's just going to equal 1. And so we don't actually need to put it right there. Okay, I want you to try letter B on your own. Go ahead and pause the video and come on back when you're done. Should take you about 2 seconds. Alright, so you should have seen that the derivative of the integral cancels out and we're left with the tangent to the fourth of x.